Mr. Andrew, before we start the class. Like the rules of the class. What is the rules?
Yeah, good evening, everyone. I welcome each and every one of you to the first facilitation we'll be having as regards um, science is concerned. And you are welcome to now once again. So, without wasting much time, yeah, because I'm giving just a minute, I will just quickly run through the do's and don'ts. Opera Jane, I will, if need be for me to respond to questions, I will let you know. So I'll quickly run through the do's and don'ts of this class or tutorial. Now, first thing first, when you are joining this class, please always mute your mic. That's the first thing that you should know. When you join, please mute your mic. So if you have any question, which I love what Opera Jane is doing, please you can actually signify by raising your hand. You don't need to just probably open your record and start talking, no, or voice note and start talking, no. The only thing you should do is raise your hand when it be for you to ask any question. You will be called on, and when you are called, you can actually raise your question, and I believe there will be answer for that. That's the second thing you should note as regards this class. So that is those are the things that you should note. And as the class goes on, you will know more about this class. And I wish you guys um, best of luck and success as you embark on this journey. Thank you very much.
Okay. Thank you very much, Mr. Andrew. Thank you very much. Thank you very much, Mr. Andrew. So we're gonna start it right now. I have my body. What we have today is maths according to the information provided. We have one. Yeah. Sorry, I don't guys. I don't mind. No problem. We have set and set theory. So these are what we have in this course. We have so many stuffs to talk about, which I believe many of us have actually passed through one or two about them before, or one or two things about them before. So once again, Mr. Emmanuel Kingsmith, you're welcome, sir. Thanks for working with us. Prodigy, we can move now. Miss Opara Jane, Ayomide, Eric Dunn, 419. Oh my God. Okay, so we're going to start the class right now. So when we mention sets, when we talk about sets, the first thing that should come to your mind is collection, set, collection, class, group. That's all we mean. So if I have, many of us know this thing we call mathematical sets. Mathematical set is exactly a collection of mathematical instruments. So that set now consists of, look at the mathematical set. Mathematical set consists of what? The ruler, the pencil, protractor, and the light. See what? Let me take eraser. So this mathematical set now is a set. What type of set is it? It is a mathematical set. That's what we're talking about. And ruler, pencil are the things, the materials we can find in the set. So those materials we can find in the set, we call them the elements. Elements. Please be moving with me. Set is a collection of objects or materials. So in mathematics, mainly, when we talk about combinatorics and number theory in mathematics, set is a collection of data. Let's take it that way. In number theory and combinatorics, set is a collection of data. So the data might be this, and the likes. So now the data that we can find in a set, a particular set, each datum is known as an element of that set. Now, I start my work. This is a set A. The first rule is that this set A can never be denoted as A. A set is always written with a capital letter. Set A. So can never be written this way. So set A equals, this is the bracket that contains the element of your set. This is the bracket that contains the element of your set. We call it the brace. We call it the brace or the curly brackets. We call it the brace or the curly bracket. It opens here and closes here. So this is set A. Set A consists of A, B, C, D, E, and stops there. I close this set. Everyone look at it very well. This is the name of the set. This is set A. So to write this now, say set A consists of A, B, C, D, E. So why are the elements written in small letters? They are written in lowercase because they are what? Elements. But the set is written in uppercase because it is the set. Are we getting the point? Please. I like showing with reaction. Please, can you help me tell them what I mean? Like show with reaction. If you understand it, the type of reaction you show. So without just interrupting rudely. So if you understand it, just use that reaction here. If you do not understand it, just use the other one that Mr. Andrew will use now. Note his name. Can you see what Mr. Andrew is using now? If you do not understand. So I think those that we have here understand what is going on. All right, it's fine then. Thanks. Thank you, Mr. Andrew. Okay. We said set A must be written in capital letter. Even if it was C, will be capital letter C. Z, capital letter Z. D, capital letter D. Why? Because it is the set. It consists of all the elements. So what I'm saying here is that A is an element of set A. B is an element of set A. C is an element of set A. D is an element of set A. E is an element of set A. That's what we are trying to point at. So I mentioned the name of this bracket. I said we call it the brace or the curly bracket. So the things that the bracket encloses, the things encapsulated in the bracket are known as the elements. So A to E are what? Elements of set A. A to E are elements of set A. That's what we are trying to point at. A is an element of set A, B is an element of set A. So now in set, we don't write too much. We do most things with symbols. So now look, I'm going to write A is an element, small letter A, of A. This is a correct statement. Since this is small letter A, we can say it that it is a correct statement because the element will be in lowercase while the set itself be in uppercase. So now I'm going to ask you that can I say A is an element of A? Can I say this? Is there anyone that can answer me? Can I say A is an element of A? Are you guys with me? Oh,
Yeah, with you.
you're not answering me. You're saying you're not answering me. I said, Mr. Benjamin, you're welcome. This is for 100 level. Tomorrow is our own class. And this for first semester.
Okay, okay.
So,
Thank you. Thank you.
yes, yes,
All right.
yes.
Okay.
And thanks for that earlier. God bless you. A, A is an element of A. So this capital letter A is the one that denotes the set. And this small letter A denotes the element. So I can never say A is an element of A. I would rather say A is an element of A. B is an element of A. C is an element of A. D is an element of A. Please, if you get that, let me know. It's reaction. Mute your mic, please. You poor please mute your mic. Thank you. All right. So now this D is an element of A, looks long and quite loaded. So they write it this way with a symbol which depicts is an element. Look at it. It's a Greek alphabet. Some people write it this way. Why some people write it this way? Note what I'm writing, please. I'm not writing this. This is what I'm writing. The E that some of our English teachers write in class when they want to write English. Some teachers use this. When you want to write English, some teachers use this. So I'm talking about this or this. It's a Greek alphabet. It is called epsilon. It's a Greek alphabet, epsilon. So D is an element of A, means D epsilon A. Please, or D epsilon A. So this means D is an element of A. Do I have people getting me here? Right? Fine. D is an element of A. So when I now say this is a set, now look at this set we have here. According to this set, we know the element of set A. I can say A is also an element of A. A is an element of A according to this set, right? I can say B is an element of A according to this set. I can say C is an element of A according to this set. I can say D is an element of A according to this set I have it, and I can say E is an element of A. But now, according to this set, and you see all what encircled in the curly bracket, can we say F is an element of A? Is there anyone that will answer me here? There is no
Sure.
F here. Sure?
Yeah, yeah.
Where is F? Not sure, please. That's very wrong.
Do you mean okay?
Like, there is no F in this thing. Please try to understand me well. There is no F in this set. So, since F is not there, is it possible for me to say A is an element of set
Oh, no, no, no.
A and F is not there? If F was here now, I would say F is an element of set A. But there is no F, means F is not an element of set A. So this is how we denote that. F is not an element of set A. I cancel the epsilon. F is not an element of set A. Saying X is not equal to 2. X is not greater than 4. So this is the same as this. So F is not an element of A. F is not an element of A because F is not in the set A. Set A contains only A, B, C, D, E. F is not there. Miss Ayomide, did you get me? No, come on. Did you get what I explained? What about Mr. Eric? Now, Mr. Chukuma, do you understand what I explained now? Do you get what I'm trying to point at?
I understood you.
All right, that's good. Okay, so note this very well. A is an element of set A. B is an element of set A. C is an element of set A. D is an element of set A. E is an element of set A. While F is not an element of set A. This is the logic. Z set A. G is not an element of set A. So looking at it here, I'll try to say, let's talk about the types of sets. We are progressing gradually then. Yes. Okay. So let us just enter the types of sets. So perhaps we'll be able to finish them and we might probably not be able to finish them. One thing we do is that I won't be able to wait for you to write these things down. You can just make a screenshot of the page now. Shot now. And it's very screenshot of the page now. So it's going to be your notes if you want to go through what we learned in the class. Shall we? Okay. Types of sets. Yeah, we have so many types of sets, numerous types of sets, very, very much type of sets. But the group, the three-way, let us just type of sets. So types of sets, we have empty sets, empty or null set. We have joint sets. Please be noting what I'm writing. We have disjoint sets. Equal sets. We have equal sets. We have equivalent sets. Okay, we have infinite sets. We have finite sets. We have bounded sets. Unbounded. They are still finite and infinite. We still have more. What is it? I bet these types of sets are not coming now. Okay. Universal sets. We have the subset, which I'm going to start with. We have the
null set.
Null set, I've written that. Notice it.
Okay.
Super set. So shall we just stop at 10? Something now.
You've written proper. Okay.
Proper, proper is under subset. Proper subset. Okay, let's.
What about power set?
Power set. Power set. Power set. That's about cardinal number now. Cardinal number of sets. Thanks for reminding me that. Maybe I should even take it immediately after the superset. So You can screenshot this, please. More because I want to rub it. Okay. Let me try to be nice. Subset.
Yeah, méjì.
All right. Right. Here we are. Talking about the subset and the superset first. I'm going to explain that with this. This is a set A containing the elements E, F, G, H, I. Let me change the name of the set to set P. This is set Q containing G, H, I. So I believe you guys are very smart. I'm very sure some of you are computer science students. Sure of that. Some of you are computer science students. Some of you are even studying physics according to the introductions you made. So I believe I can get from you the similarity between these two sets. This is set P, this is set Q. What is similar between them? Anyone? Anyone from you guys? What is there?
H. H is similar between them. G is similar between them.
Thank you very much. Yeah, I know you'll be smart. Yeah. Okay. Now we are going to work with that similarity you just mentioned.
Sorry, please always raise your hand when you want to answer any question, please. Not to so that we won't distract the class. Thank you.
Thanks for that. So please, do you get that? If you want to answer any first, so it's because it's not yet exam time. That's why you guys are not this much. Mathematics is maybe I remember. Now go still pass. That is when the exam tension enters. That's why you see 100 and something people inside. So I'll work with that now. This is a set P and this is a set Q. You can see that set P has some things and set Q has just part of it. So definitely I can say set P has everything that set Q has, Abby, but set Q doesn't have everything that set P has. I'm repeating myself. Set P has everything that set Q has, while set Q does not possess all the elements of set P. I believe there is another person that also noticed that aside from me. So that means P is one set that is bigger than Q because it has what Q has and it still has what Q does not have. So P is a superset of Q. P is a superset of Q. I told you everything is denotation here in set. We denote this by this, denote this by this. This is the way of denoting supersets. P is a superset of Q. That means P has all the elements present in Q, but Q does not have all the elements present in P. Please, do you understand what I explained now? That P is a superset of Q. It is super to it. You understand? When something is super, it has extra. It has what the other one doesn't have. So that's what it means. I think it's just a person that has gotten me here. When we say P is a superset of Q, it means P has G, which is present in Q. It has H, which is present in Q, and it has I, which is present in Q. While Q does not have E that is in P. Q does not have F that is in P. Definitely P is bigger than it, right? So P is a superset of Q, while Q is below it. So we say that Q is a subset of P. Q is a subset of P. P is a superset of Q, while Q is a subset of P. Please, do you understand? Let's know. Let's know now. Let's know now. It's your stickers, please. Just let's know with your stickers, please. Others are not responding. Why just ignore you? All right. So I believe Miss Amiri is the only one moving with me then. So let's take it that way. Yeah, you're supposed to just do this very fast. You just do it fast. You're actually wasting my time now. So P equals, again, because of the person using that reasoning sticker, thinking sticker. So P equals EFGHI and Q equals GHI. So P has F, it has E, it has G, it has H, it has I. So the element of Q are just GHI. The G is present in P. It is also present in Q. H, I, are you together with me? So EF is not present in Q, but you can see that P has packed all the elements in Q finish, but Q couldn't pack all the elements in P. Because of that, because P has the superiority of packing all the elements in Q finish, definitely P is a superset of Q. It is superior over it. It is a superset of Q. Why? Because Q is below P. So Q is a subset of P. So the conclusion is that P and Q have elements that are similar. They have similar elements. They have at least one similar element. And now they have about 3 similar elements. So we say that P and Q are joint sets. Why are they joint? Because there is at least one element that is similar between them. And it's even more than one. We have 3 elements similar between them. So they are joint. And even there is no element similar, that P equals A, B, C, and Q equals E, F, G. You can see there is nothing similar between them. So I will say set P and set Q are disjoint sets. I will say set P and set Q are disjoint sets. While if they are similar to each other, I will say they are what? Joint set. If they have at least one element that is similar to the both of them, that is within P and it's in Q too. So I'll say the both of them are joint sets. So again, P equals this. So P is a superset of Q because it is superior over Q. It has all the elements of Q. But Q doesn't have all the elements of P. So that's why Q is subset of P. Q is a what? Subset of P. Look at what I'm using to denote it. It's not C. Yeah. P is a superset of Q. Q is a subset of P. So if P, are you with me, please? I hope I'm not just talking. That's what actually annoys most. Oh, no, so if P is a superset of Q, definitely P cannot be a subset of Q. P is a superset of Q, so it cannot be a subset of Q. You can just say P is not a subset of Q. And if Q is a superset, if Q is a subset of P, so Q cannot be a superset of P. So Q is not a superset of P. Just cancel it. That is what that thing means. Not means just cancel it. Please, are we getting it? Opara, I'm not seeing your YouTube. No, I will. Clapping. Are you getting it? Okay. P and Q are joint.
Yes.
Do you have any question? Okay. So this about 3 things we've explained now. We've explained joint set, disjoint set, we've explained subset and superset. When 2 or more sets are joint, definitely there is at least an element that is similar between them. This is set A containing A, B, C, and this is set B containing C, D, A. there is one element similar. That element is what? C. C is in A and it is in B. So A and B are joint sets. That's it. So look at this now. A equals EFG and B equals HIJ. You can see there is no element similar between the both of them. No element similar in the two sets. So I'll say A and B are not joint in any way. They are disjoint sets. A and B are disjoint sets. That's what that implies. That is what it means. The last thing I will explain before we end this class is cardinal number. Please, Dr. Sancho. So in the next class, I'll just continue explaining the types of sets. I actually want to explain the cardinal number tonight. So, and I will stop there. Stop there actually. Because we've been here since 9:15. You guys prolonged the beginning of the class, so it's not in any way our own fault. So, shall we rub it off? Cardinal number of a set. Very simple. Cardinal number of a set. What we mean by cardinal number is very too simple. Look at this. This is set A. It equals E, F, G, H, I, J. And this is another set G. It has the elements Q, P, R, S, T, U, V, W, X. So this is another set Z. Contains 1, 2, 3, 4, 5, 6, 7. This is another Z. Let's stop here. These are three different sets. So when we talk about their cardinal number just means the number of elements in a set. We've defined what an element is. An element is what it contains. So how many elements are there in set A? 1, 2, 3, 4, 5, 6. So we say the cardinal number of set A is 6. So how do we write that? We write cardinal number of set A is what? 6. Number of A, 6. That's what we mean by the cardinal number. So this set G contains Q, P, R, S, T, U, V, W, X. How many numbers does it have? How many elements does it contain? Knowing the number of elements means knowing the cardinal number. Q, P, R, S, T, U, V, W, X. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the cardinal number of set G is what? 9. And this is the last one, set Z. Set Z contains 1 to 7. So the cardinal number of set Z is 7, as simple as this. Any question? Like if you understand that, let's move straight away. You understood what's happening now. All right. All right then. So I think let me entertain any question at the moment. Any question from anyone? Any question about what we've explained so far since the beginning of the class? Please raise your hand before talking. That's a rule here. It's a rule. Before unmuting your raise your hand. Please, any question from anyone? Is it that you guys understood what happened? What we did? Did you understand it? Okay. 1, 2. Like from the beginning of our explanation, that's what I'm talking about. 3. You can see this Mr. Liam is now with us. So Michael. Michael, do you understand? Okay, I think Michael is not also with us. So I'm happy I was able to carry Miss Ayomide, Mr. Opara, or Miss Opara, and Mr. Chukuma along. That's very good. So, Mr. Andrew, thank you very much. Sir, Mr. Emmanuel, thank you very, very much, sir. So I really appreciate you guys. I think we can call it a day. Prodigy, you know too fast. I think we'll call it a day, Jerry. I think we've done one or two things actually. What do you think, bro? So the class will always be continuous if you are ready. If you are ready. So we actually know what we went through. That's why we are ready to help. But some people do not take it serious. It's their fault, though. So I hope God helps everyone. What did you
Yeah,
mention?
thank you so much, Ali.